In this video, I want to look at finding the expected value for discrete variables. So the first question, what is the expected value? Well, the expected value is just another name for the mean, or the average. So let's look at how to find the mean, or the expected value, for a discrete random variable. We're going to let S be the sample space for our variable. We'll let P of X be the probability mass function, the PMF. The expected value is denoted by E of X or by a mu, sometimes with a little x to denote which variable we're talking about, but a mu, the Greek letter mu. And this is the summation of all the variables x in our sample space of x p of x. So we're going to multiply each value by its corresponding probability given in the PMF, and then add all of these values up. So let's look at some examples. Let's suppose the population of interest is a batch of 100 units, 10 of which have some type of defect received by a distributor. An item is selected at random from the batch and is inspected. We're going to let our random variable x take the value of 1 if the selected unit has a defect and 0 otherwise. And I want to find the expected value. We need to start with the PMF, the probability mass function. Well, the possible values that x can take are 0 and 1, depending on if it's defective or not. 1 means the item was defective. There are 10 with a defect out of 100, so 10 out of 100, or 1/10. And that means 9/10 do not have a defect. So this is my PMF. To get my expected value, E of x, or mu, I need to multiply and add. So I'm going to multiply 0 times its corresponding probability. And then I'm going to add 1 times its corresponding probability. So this is 0 plus 1 over 10. So the expected value is 0.1. An extension of the previous problem, let's select a product item from a production line, and we're going to let x take the value of 1 or 0 as the product item is defective or not. And we're going to let P be the proportion of defective items in the conceptual population of this experiment, and I want to find the expected value. So here, my values for x are still 0 and 1. The probability that it's defective is P. So the probability it's not defective is 1 minus P, since these two values do need to add up to be equal to 1. So my expected value, I would multiply down this column. So 0 times 1 minus P. I then multiply the second column and add that in. So plus 1 times P, which is equal to P. So if my only possible outcomes are 0 and 1, the probability of 1 is in fact the mean. Let's look at one that's slightly more complicated. Here, my probability mass function is given. My possible outcomes are the numbers 0 through 6, and I have their corresponding probabilities. And I want to find the expected value. For this one, I'm going to start by introducing another row to this column, or to this table, and it's going to be x p of x. I'm going to multiply down. 0 times 0.1 is 0. 1 times 0.15 is 0.15. 2 times 0.17 is 0.34. 3 times 0.21 is 0.63. 4 times 0.23 is 0.92. 5 times 0.09 is 0.45, and 6 times 0.05 is 0.3. And then I need to add up these values. 0 plus 0.15 plus 0.34 plus 0.63 plus 0.92 plus 0.45 plus 0.3. When I add all of these values up, I get the expected value, which is 2.79.